A warm welcome, my dear friends. A very good morning, good afternoon, good evening to all of you. And this is the data analysis and decision making course under the NPTEL MOOC series. And as you know, this is a 12-week course for 60 lectures, 30 hours, and each week we have 5 lectures, each being a duration of half an hour or 30 minutes. And we are in the 29th lecture, which is basically the last but one lecture for the 6th week. And if you remember, the last day we basically spent a whole lot of time trying to understand the concept of QQ plots, normative plots, and technically the number of slides, if you consider covered, was not much, only maximum 3 or 4. I will rehash that and continue the discussion with normative plots and other concepts of multiple linear regression. And as I said, I made a change in the analysis of the multiple linear regression. I will basically do it during the multivariate statistics. So, as I said that we need to check for the normality. So, the normality, what we do is that I will again read it, because we have already done it once and using the Excel sheet. So, we list the observation numbers in column 1, call it as I, then list the data, actual data for which you are going to do the QQ plots and try to verify them. We list the data in column 2, then sort the data which you have already collected, which is in column 2, that will be sorted out in column 3 from the least to the highest. Now, for each of the I, which is basically on the first column on the observations, we find the corresponding tail area of the standard normal distribution using the formula, which is as A is equal to I minus 0.375 divide whole thing divided by n plus 0.25, and then you will basically use the norms inverse function of A to find out the column number values in column 5, then plot column 5 and the sorted out data, try to find out how the straight line is. Technically, if it is a normal distribution with respect to the standard normal distribution, I am talking about the data, then you know it is a standard normal distribution. Now, the reason why then I spent a lot of time trying to basically give you the essence what we mean by QQ plots. This I had drawn. So, this is the data which I have here. I will basically use the highlighter as needed. So, I will just won't basically write much, because or else this whole thing would become too cluttered. So, this the column where I am hovering my pen are the corresponding z values. You have the corresponding values for the distribution, and you basically do a 1-to-1 map. That means, because the CDF covered between any distribution is always 1 total CDF, and corresponding to any x, any z, you find out the corresponding CDF values, equate them. If you are equated, they have been basically mapped onto a 1-to-1 scale. So, for each, so this green and red one which you have written are exactly the same calculations, but for different values. You find out the CDF of f of y, and then basically this is a discrete or a continuous, whatever it is, then map it with the standard normal deviate, what is the area, and basically say that value of z from the standard normal deviate and the corresponding value of y for which the CDF value is equal to the standard normal deviate CDF, we say that they are equivalent, and then basically plot it accordingly. So, when we are plotting along the x axis, I will just I have a diagram in the next page. I will basically do it. So, next to next, please hang on. So, this is what we said, that integrate it from minus infinity to z, find out f of z, and then equate it to the CDF value for the corresponding y distribution and calculate accordingly. And the green graphs which are there, they are basically the CDF for the z distribution and CDF for the unknown distribution, such that we can compare. Now, when we plot, this is what I wanted to say. When you plot, you have the normal scores are along on the x axis and the corresponding sorted out data points are along the y axis, and what we do is that for some unit movement along x axis, you will cover basically the z values, small z values, that will have a corresponding distribution, no, corresponding CDF, my apologies, and that CDF value would also correspond to a certain value of x for the unknown distribution. So, if the quantile plot values for equal quantum of quantile on the x axis and equal quantum of quantile on the y axis, they have the same CDF value, then the unit of length moved along the x axis and the unit length of length moved along the y axis to cover the CDF values are exactly the same. So, the line joining would be a 45 degrees line, which means the corresponding quantile match and the corresponding distribution which we have is basically the z1 and the unknown one, which is x distribution. We are basically denoting it by the random variable x. If the values match, then obviously it means that the quantile to quantile values are same. So, technically I am just writing here the quantile value should be exactly as 45 degrees line. Along this you have z, and along this you have x, which is unknown, and if these values match. So, if the quantile, let me use so these values are along for 45 degree line, then obviously the quantile plots are same, hence it is a normal distribution for x also. So, now we will consider some transformations for the multiple linear regression model considering normality is true. So, in general we will basically transform to x to the power p, where p can be a value starting and can be any integer, non-integer values. So, the transformation is given by x to the power p minus 1 by p, and p can take any value. So, as p tends to 0, that transformation which is x to the power p minus 1 by p basically becomes the Neperian log to the power base e. Now, if the variability in y increases with an increasing value of y, and in that case you want to basically bring normality in the data set such that you are able to forcefully bring normality, in the sense for the calculation part, you are not doing in practicality. You want to bring them normality for the calculation, then what you do is that convert the values, y values or x values, whatever it is, into the log scale. But the problem is that in the normality scale, the values technically should be from minus infinity to plus infinity, which may not be the case when you are considering the log scale. So, this has to be basically analyzed from the data analysis point of view. Few of examples of nonlinear regressions are, if you see the first one, you have basically beta and alpha and gamma in the numerator and denominator, hence trying to find out the sum of the errors squared up. Obviously, when you try to differentiate with respect to alpha and partially differentiate with alpha, beta and gamma, would not basically give you simple linear equations, they would maybe quadratic or other polynomial one, hence trying to find out the betas, alphas and gammas using the concept of multilinear regression would not be possible. Other equations which gives you the relationship between y and x would be the second one, which is y is equal to alpha into x in the bracket x minus beta through the bar gamma. The third and fourth one are with respect to the relationship of logarithmic of x into given with the relationship of y. But the only problem here why it has become complicated is that because gamma is inside the logs, hence trying to find out the partial differentiation these values and putting to 0, trying to solve them may not be straightforward. So, the last one is where you basically have the relationship of x and y given the exponential function. For all these values, another method we basically our main aim is to minimize the sum the square of the errors and try to basically find out alpha, beta, gamma using the alpha hat, beta hat and gamma hat corresponding to the fact that you are basically differentiate partially with respect to these parameters. So, now we will start basically a little bit go the quantum of understanding would change. So, we will basically consider the multivariate statistical analysis, and whatever you have studied in almost 30 lectures, we will try to basically utilize that in the remaining 30. So, I thought that it is good that I go into details about simple univariate statistics and give you this information, so that you are able to handle the multivariate case in much better way. So, considering this example, it will be more example based, because that will basically bring out the flavor of the discussion. As a dietitian in the hospital, you are considered on one of them, a very big hospital, say for example, Just Lok or Ram Manohar Lohia or Calcutta Medical College, whatever it is, or AIIMS. So, you work there, and in the hospital, one is you are basically interested to study the physical features of the patients who are admitted or who come for cure or medications, whatever, and you want to find out the relevant parameters, because the dietitian wants to find out the relevant parameters, because he or she will tell the patient what should be the diet, what should be the amount of carbohydrate the person should take, what is the amount of protein one should take. If he or she, the patient is a diabetic one, so what should be the rules and regulations for food, whether the person should take fruits or not, and all these things, or whether if somebody is allergic to milk, which is lactose intolerance. So, then how would you basically analyze the food habits, as that you need the parameters, basically you need to know some values of the human being as such, the patients whom you are going to treat. So, things relevant for the studies are body density, what is the body mass index. So, in many of the cases you try to find out the ratio of the height to the weight, then what is the fat content in the body, and all these things are there. You basically get, or the dietitian gets all this from the patients who undergo treatment in the hospital. The dietitian job is to basically decide the right diet plan, because as I said, a diet plan, whether the amount of food calorific value should be high, low or maintained. Maybe some people have been told due to their restrictions that the amount of water has also been to be maintained at a certain level. So, it is basically to decide the right diet plan based on the data information like percentage body fat, what is the age of the patient, what is the weight of the patient, what is the height of the patient, etc. is important to be noted now. So, for this, let us use the data. I am trying to basically use data in the real sense, what is available in public domain, and which is used by different type of people in order to study these different concept based on which the data has been uploaded or being discussed. So, let us consider the data which is there in University of California, Los Angeles, and it consists of a sample set of 252 patients. So, all the different things are given for patients. Please have a look at the data, you will understand. So, here is I am more of a interest making session, where you will basically understand why I am citing these examples and what is the relevance of them. So, the data consists of a sample set of 252 patients, as this enables you, who is the dietitian, to do a detailed study or analysis of the different characteristics like body fat index, height and weight using a 3-dimension scatter plot. So, I will basically use these 3 different variables or parameters in order to understand how the multivariate set of informations can basically be gleaned, such that you at one go with a diagram you can understand how it basically is. So, in the next slide you have basically the diagram which gives the 3D diagram. Along the x axis you have body fat index which is here, then along the y axis you have the height, and along the z axis which you have the weight. So, height and weight are basically measured in centimeters and kilograms. So, all the scatter plots, the blue circle points which you see in the diagram, they basically give you, so what is the corresponding different 252 values which are there. So, if I consider, say for example, arbitrarily, let me consider this value, this person. So, in that case the person's body fat index, if you drop a vertical, the body fat index would be about 42. I am just arbitrarily given. If you go in this way, that means, so basically I go here and I want to touch the y axis. This is the plane here which basically is the height. So, basically it will be somewhere, it is in between, so 170 and 60. So, consider it will be about 165. So, basically drop vertical here. So, this is 165, value is 42, and basically I want to find out that what is the weight of that individual. Again I go in the orthogonal direction and basically I hit the weight one. So, weight one comes up to this. I am trying to do a crude method, trying to make you understand. So, this is the value of the person is on the weight, which would be about 96, 97. This is the height, which is about 167, and this is about 142, only 142. So, this person basically has the values of height, weight and body mass index as given. So, you can basically find out from the 3D where the particular person stands, and obviously, if you have a threshold, the threshold can be either for the weight, either for the height or the body mass index. Based on that, you can say yes, these people basically need to be careful about their diet, hence you will basically take actions accordingly. Consider the next data set. It is basically again it is a different example. A real estate agent in the state of California in USA is interested to forecast the median household value, not the mean, median. So, based on that, the real estate, if he knows the median households, and obviously he can, in case if he is buying the house, he is not duped and basically knows that what actually the price of the house should be, and when he is also selling the house, he should also give the right information to the customers and not basically go for a loss, or not basically see to that that the business proposition based on which he is doing his business really is profitable. Now, in this case, why we take the median one? Because rather than mean, median would basically give me a better indication how the distribution is. So, it basically divides the whole distribution into half and half. So, the real estate, he or she has about 20,640 data points, which is a huge data set, which consists of information along for the data set. For any of the other points of the data set, you will basically have the median household value, the median income for the people who are there, what is the housing median age. So, obviously, different house have different age. So, you want to find out the median age, what is the total number of rooms in that house, what is the total number of bedrooms which is house, what is the population, what is the household numbers, and so on and so forth. So, they are basically denoted by MHV, which is the median household, median income MI, housing median age HMA, total number of rooms TR, total number of bedrooms TB, population P, and household H. So, obviously, there were other set of information also. If you, when I come to the data source about the longitude and latitude of the place for the each and every houses, like those 2,640 data points had their location also, but that is not necessary for our calculation. So, I have not mentioned it, but if somebody is interested, he or she can definitely have a look at the source. This information about the data set can be obtained in the paper titled Sparse Spatial Autoregression by Kelly and Berry in the Statistics and Probability Data, which came out in 1997. So, first let us fit the, we will basically fit the multiple linear regression. The models, everything is there. I do not want to go into details, I will come to that later on when we will be doing the multiple linear regression. So, let us fit the multiple linear regression MLR model as used by the authors to this data, and we will basically use the exact formula which has been used by the authors. Then we will obtain the ordinary least square regression coefficients. Obviously, these regression coefficients of the betas, if you remember, we will consider them that they are the sample one. Even if the data size is 20,640 is huge, but still we will consider the data size based on which we are doing that study is just a sample. So, they would basically be the estimate. So, the estimates we denote by suffix e, and that bold beta is basically the vector. So, in this model we consider there are 9 betas starting from beta naught. So, it will be beta naught, beta 1, beta 2, beta 3, and each would basically have their own significance. So, beta naught would basically be the one for which is the coordinate at which the straight line linear regression best fit cuts the y axis. So, obviously, multi-dimensional case it would be plane, not a line, which is basically hyperplane, because it is easy to understand in the 3 dimension case, may be a little bit difficult to understand in the higher dimension. So, the values corresponding to beta naught to beta 8 are given as 11.49, then 0.47. I am only reading the 2 places of decimal correspondingly, then 0.01, 0. It is almost 0. So, beta 3 would be 0 estimated value. Beta 4 is 0.15, beta 5 is equal to 0.85, beta 6 is 0.80, beta 7 is minus 0.40, beta 8 is equal to 0.04. So, here the suffix e is the estimated value. So, we have found out the betas, and what is needed to be done is, say for example, thus if you want to know the forecast of the 2621st reading, which is given in the data as I have this I should mention. I am considering, because this is such a huge data, I can take random sorting and then sort them out and basically find out any value which is the I arbitrarily consider from the same huge sample of 20,640. And then basically that value is 11.512, this is 2620. So, obviously, I randomly take the 20621 value, and then using those betas I forecast them. The value comes out to be 12.33. I am again reading only 2 places of decimal, and this results in an error of about 0.81. Let us consider the third example. A faculty member in any of the IIMs or good management institutes or an engineering institute, whatever, he or she is interested to study the change in the prices of 7 stocks which are being sold and bought in the stock exchange, whether NSE or BSE, and the stocks are been generally Bajaj Auto, Maruti Suzuki, Tata Motors, Steel Authority of India, Tata Steel, Infosys Limited, and Tata Consultancy Services, which is TCS. And the data points are starting from 1st January 2014 to 31st January 2014. So, we have, say for example, technically the total number of days is 360, 364 or 365, but the trading number of days would be on an average 240. So, we are basically using 240 number of data points basically to find that out. So, now we want to basically find out in which directions the prices, or not the prices, in what clusters these different type of stocks would be. So, whether they are the same clusters, whether they are different clusters, whether does it mean that Bajaj Auto and Steel Authority of India would be in the same cluster. So, we have to basically do it. The faculty member uses the prices of these 7 stocks from National Stock Exchange, as I mentioned, which is given. The second URL is the National Stock Exchange, but you can get the information from Yahoo Finance also. So, these URLs are given. Now, before he or she does the analysis, he or she looks at the data. A closer look convinces the faculty member that the price movement for the first 3 scripts, which is basically Bajaj Auto, Maruti and Tata Motors, the next 2 which is Steel Authority and Tata Steel, and the last 2 which is Infosys and Tata Consulting Services, move in tandem. That means, the price movement for Bajaj, Maruti and Tata Motors move in the same direction, the same manner, not exactly same, but in the same manner. Then Steel Authority and Tata Steel move in the same manner, but obviously that is different with respect to the first group. And the last 2 which is Infosys and TCS also moves in the same manner, which is different from the first and the second one. So, we want to basically find out these groups and name them as automobile sector, steel sector, information sector, and just check whether the proposition which you are making that they move in with respect to the sector is right or wrong. The guess is valid, and we will see that later on, that as the companies that are in the same sector tend to vary together as economic conditions change, and this factor is also substantiated by the factor analysis diagram which you have given. I am just mentioning factor analysis, I will come to that later on. So, this is the factor analysis which I do. So, let me highlight. So, 1, 2, 3 which is basically for the auto sector, they are moving in tandem in this direction, while 4, 5 which is basically the steel sector, they are moving in this direction. The angles would be important later on. So, basically they are not orthogonal, and the last 2 stocks which we have considered as TCS and the other company Infosys, they move in this direction. So, they are not orthogonal, but obviously their co-movements are similar. So, you 6, 7 compared amongst them, or you consider 1, 2, 3 compared against them, if you consider 4, 5 compared against them. So, they move in the same direction. Now, in all these 3 examples, what is important to note is the fact that given a multi-dimensional data set of x, and this suffix n cross p is basically the dimension, n number of rows, p number of columns. It could have been basically k also, n into k, but I am basically if you remember, I did mention k at one point in time, but we will consider p, and the size of the matrix, whether it is p cross n or n cross p, that is only the nomenclature concept, but generally the dimensionality should be checked for each and every matrix multiplication and addition. This is of size n cross p. The user, whether he or she is a dietitian, the real estate agent or the faculty member, all of them are interested to draw some meaningful conclusion from the data using a set which has p number of variables. What are the characteristics? I am not going to come to them immediately, and n number of data points, and the size of the study is basically known as multivariate statistical analysis. And if you remember, I did mention some of the properties of the multiple linear regression, that the covariance between x's being independent, then the covariance between error and x's is independent, covariance of the errors themselves is 0, and there is a mean value for the x's, mean value for the y's. So, all this thing, and then the errors would be distributed with mean value of 0 and some standard deviation. For the simplest case, we consider 1 and so on and so forth. So, we will consider all these things in much detail. This is just a warm up one, and we will go through the characteristics in multivariate statistics slowly, and I am sure you will understand it. But having said that, the concept which we are considering in the univariate case would be repeatedly used as we proceed in the multivariate statistical analysis. With this, I will close this 29th lecture, and thank you very much for your attention. Have a nice day.